Okay, we're given one of the zeros. We're given that f of negative 5 equals 0. And then we're going to use that to find the complex zeros of this one. Okay, so it's nice that they give us one of the zeros already. So now we already know what number to use for synthetic division. You don't need to take the opposite sign of this. Again, we're not doing that. You're going to use whatever number is on the inside that they give you. So if they give you negative 5, that means that I want to use negative 5 with my synthetic division. I'm going to go ahead and put down my coefficients there. That's already written from highest to lowest power. So therefore, because the powers are written that way, I can just go ahead and put the coefficients in as is. And then I'm going to do synthetic division steps on it. We bring down the 1, multiply that, negative 5, add that together, you get 8. Multiply negative 40. 57 minus 40 is 17. Multiply 17 times negative 5, that will give you negative 85, so you do in fact get a 0. We expect that we should get a 0 because it says that if I put negative 5 in there, I get a 0 result. That should always equal your remainder there. That's your remainder theorem that says that. And what do we have left? We're going to, it was a third power raised to the power of 3, and so now we're going to put in our coefficients, x squared plus 8x plus 17, and now we want to set that equal to 0. Now the problem with this is we're not going to be able to factor this one because two numbers that multiply to make 17 and add to be 8, that doesn't exist. So whenever that happens where you can't factor something, you have to go to the quadratic formula. Your a is going to be 1, your b is 8, and your c is equal to 17. We're going to put these numbers into the quadratic formula and we're going to work that out. So you have negative b, so we have negative 8 plus or minus b squared minus 4ac, so we have 8 squared minus 4 times a is 1 and c is 17. All that's going to be over 2 times 1. Okay, so now we have to work this out on the inside, and when we do, we're going to get negative 8 plus or minus the square root of 64, and this will be minus 68 divided by 2. We notice that we are going to have a negative number under the square root, which is good because it says that we should get a complex 0. That's what it means. Complex 0 means that we will have an I in our answer. So I do want to break this down as much as possible. If you want to review the section about I's, there is some videos on that working with complex or imaginary numbers. So you want to go ahead and check that one out just to review this. But what you would do is you would subtract that and you would get negative 8 plus or minus the square root of negative 4 all over 2. I'm going to turn this into an I. The square root of 4 is going to be 2. And then because I have a negative underneath there, that's where the I comes from. So I get negative 8 plus or minus 2I, and all that's going to be over 2. You take everything on top or divide by 2, so you get negative 4 plus or minus I. That would be as far as you can go. So again, I divide the first one by 2 and I divide the second one by 2. Make sure you divide both of them because really what you're doing is splitting this up into two separate fractions. You're really doing this. You're doing negative 8 over 2 plus or minus 2I over 2. So that's really the intermediate step that you're doing there. You're always separating it in two different fractions because you always want to write in the standard form a plus bi, as was mentioned before in that section regarding complex numbers. So therefore, this is going to be your final answer. The real number part, negative 4, and here's your imaginary part, that's the I.